A tiny world spins wildly in the frozen dark, defying every rule we know. This is Varuna, a dwarf planet hiding in the distant Kuiper Belt, and its existence challenges the fundamental story of our solar system. By the end of this journey, you will uncover 25 of its deepest secrets, each one a cosmic puzzle waiting to be solved. How can a world this size whirl so fast it should tear itself apart? And why is its surface so mysteriously dark? What is the one mystery of our solar system you find most compelling? Its rapid spin is the first clue that something is deeply unusual here. Varuna completes a full rotation in just 6 hours and 20 minutes. For a world nearly 700 kilometers across, this speed is staggering. Think of a figure skater pulling their arms in to spin faster. Now imagine that skater is a small planet, whirling so violently that the centripetal force should, by all rights, fling its own material into space. Yet Varuna remains intact, a solid ball of rock and ice spinning in the void. How does it hold itself together against such tremendous forces? The answer likely lies deep within its hidden interior. One compelling theory suggests Varuna is not a loosely packed pile of rubble, but a remarkably dense and solid body. Its gravity, stronger than we might expect for its size, could be the glue that binds it, preventing a catastrophic disintegration. This points to a composition far richer in rock than in ice, a world with a surprisingly massive core. Another possibility is that it is a so-called contact binary, two smaller bodies that gently merged in the ancient past, creating a single object with a shape stretched by its own rotation, like a spinning water droplet. This formation story would explain both its speed and its stability. Its whirlwind dance is a relic from its birth, a fossilized record of the chaotic collisions and mergers that built our solar system. What other secrets are locked within that dizzying spin? That frantic spin may hold the key to Varuna's second great mystery, the profound and puzzling silence surrounding its atmosphere. For a world of its size, located in the deep freeze of the Kuiper Belt, the complete lack of a detectable atmosphere is startling. This distant realm is so cold that volatile compounds like methane, nitrogen, and carbon monoxide, which would instantly boil away into gas closer to the sun, should remain frozen solid on the surface. Scientists fully expected to find at least a thin, seasonal atmosphere clinging to Varuna, a temporary cloak of gas released when its odd, elongated orbit brings it slightly closer to the sun's warmth. Yet our most powerful telescopes have detected nothing. The void around it remains empty. This absence forces us to reconsider what we know about how such distant worlds operate. One compelling explanation points directly back to its incredible rotational speed. A world spinning that fast has a very weak grip on its own surroundings. Any gas molecules that do manage to vaporize from the surface would be flung out into space almost immediately, unable to coalesce into a stable atmospheric envelope. It is like trying to form a persistent cloud of steam around a rapidly spinning top. The motion simply scatters it. Another possibility is that Varuna's surface is composed of much more stable, less volatile ices than we predicted, or that it has already lost all of its easily vaporized materials over billions of years, leaving behind a barren, ancient crust. This atmospheric void creates surface conditions of almost unimaginable stillness and cold, a landscape permanently exposed to the vacuum of space. What does the utter lack of an airless sky tell us about the true nature of this dark and rapidly whirling world? That profound stillness and cold lead us directly to the third mystery, a characteristic you can almost see with your own eyes: Varuna's unnaturally dark surface. Most icy worlds in the outer solar system are brilliant reflectors, shining like dirty snowballs because their surfaces are covered in freshwater ice. Varuna, by stark contrast, is one of the darkest objects we know of in the entire Kuiper Belt. Its albedo, the scientific term for how much light a surface reflects, is shockingly low. Imagine the difference between a field of pure white snow and a pile of fresh asphalt. The snow blazes with reflected light, while the asphalt absorbs almost all sunlight, becoming dark and hot. Varuna is the cosmic equivalent of that asphalt, a shadowy world that swallows light rather than returning it. This is not a minor difference, it is a fundamental anomaly that sets it apart from its neighbors. What could possibly coat this distant world in such a profound darkness? The answer points to complex chemistry happening in the deep freeze. One leading theory involves the long-term effects of radiation. Over billions of years, the weak but persistent flow of cosmic rays and solar wind striking Varuna's surface could be transforming simple ices like methane and water into dark, complex, carbon-rich compounds. These are called tholins, a sort of primordial tar that paints distant worlds in shades of reddish-brown and deep black. Another possibility is that Varuna's surface is simply ancient, its original bright ices long since buried under countless layers of dark dust accumulated from cosmic collisions or never present to begin with. This unique darkness suggests a composition and a history entirely its own, a world that has either been baked dark by eons of radiation or one that formed from intrinsically darker, more primitive materials than the other icy bodies around it. Why has this specific world undergone such a dramatic darkening process when others have not? The secret must be written in the faint, dim light we struggle to see from Earth. This profound darkness may be a direct clue to what lies beneath, pointing us toward the fourth and perhaps most fundamental mystery, the conundrum of Varuna's true shape and density. We cannot simply send a probe to take a picture, so astronomers must rely on subtle tricks of light. By carefully watching how Varuna's brightness changes as it spins, they can infer its form. The data paints a picture of an object that is not a perfect sphere, but something stretched and elongated. It is the shape a ball of dough would take if you spun it rapidly between your hands. This fits perfectly with its incredible rotational speed, a world stretched by its own motion. But here the puzzle deepens because its estimated density tells a conflicting story. Is Varuna a fragile rubble pile, a loose collection of ice and rock held together by its own meager gravity, or is it a much more solid, unified world? If it were a simple pile of rubble spinning that fast, it should have flown apart eons ago. The fact that it remains whole suggests a surprisingly robust interior, a higher density that points to a significant amount of rock mixed with its ice, giving it the gravitational strength to withstand its own whirlwind dance. This creates a tantalizing paradox. Its elongated shape hints at a relatively loose structure, yet its survival demands a surprisingly solid one. One elegant solution is the contact binary model, where two smaller, dense bodies gently merged in the early solar system. Their union would create a single, elongated object with a strong, consolidated core, explaining both the shape and the density in one stroke. So is Varuna a single stretched world or two that became one? The answer determines not just its form, but the very story of its birth. The paradox of its shape and density is written in the faint light it reflects, a light that holds the fifth mystery, Varuna's confounding surface composition. When astronomers analyze this dim glow, they uncover a landscape of contradictions. Spectroscopy, the technique of splitting light into a rainbow to reveal the chemical fingerprints of distant worlds, shows the clear signature of water ice. Yet this ice does not create a bright, reflective surface. Instead, it seems to be masked or perhaps corrupted by something much darker and more complex. The data hints at the presence of complex organic molecules, the very building blocks of life, mixed intimately with the frozen water. This is not the clean, simple surface of a frozen snowball, but a messy, chemically rich tapestry that defies easy explanation. Why does this particular mix of materials create such a uniquely dark and red-colored surface compared to its neighbors? Other trans-Neptunian objects might have bright patches of pure ice or different coloring, but Varuna's recipe seems specific to it. One possibility is that its rapid rotation and elongated shape create unique temperature extremes across its surface. This could trigger complex chemical reactions in some areas but not others, leading to a patchwork of different materials that, from our distant vantage point, blend into a single mysterious hue. Another theory suggests that the dark organics, those tholins, are not just a thin coating but are deeply baked into the ice itself, a primordial soup that has been cooked by radiation for eons. The presence of these organics transforms our understanding of this distant world from a simple ball of ice into a potential repository of ancient carbon-based compounds. What does it mean for the ingredients of life to be so prevalent on such a dark and isolated world? The answer is frozen into its very skin, a cryptic code that we are only beginning to decipher. The cryptic chemistry of its surface leads us to a mystery of a different kind, woven not from data but from mythology. This distant world bears the name Varuna, drawn from the pantheon of ancient Hindu deities. Varuna was the god of the cosmic waters, the celestial ocean, the ruler of the night sky and the eternal rhythms of the cosmos. It is a name of profound weight and poetry, chosen for an object so distant and enigmatic. But does the name, bestowed by its discoverers, hold an uncanny resonance with the physical reality of this dwarf planet? The connection seems almost prophetic. The god Varuna was a sovereign of the vast and hidden deep, and this cosmic body is itself a denizen of the deepest, darkest ocean we know, the outer solar system. Its composition, likely rich in water ice, silently echoes the deity's elemental domain. More strikingly, the god was associated with law, order, and the cosmic balance, often depicted with a noose to bind that which was out of place. And what is this spinning world if not an object that defies our established laws, a cosmic rule breaker held together by forces we do not yet fully comprehend? It is as if the ancient name has bound this modern discovery to a theme of profound mystery. Is it mere coincidence, or does it suggest that some truths about the universe are reflected in our oldest stories? This layer of cultural enigma invites us to see Varuna not just as a collection of scientific data, but as a character in a much older, grander narrative. What other secrets might be hidden in the space where our science and our myths unexpectedly converge? The myths we wrap around this world cannot obscure the raw data it sends our way, a flickering signal of light that holds its seventh mystery. As Varuna spins in the darkness, its brightness does not simply wax and wane in a smooth, predictable rhythm. The pattern of its light curve is complex and uneven, a stuttering pulse that a simple elongated shape cannot fully explain. If it were just a stretched oval, we would see two symmetrical peaks in brightness during each rotation, one for each of its long ends turning to face us. But the light tells a more complicated story. There are bumps and dips in the pattern that defy this simple model, suggesting that something else on the surface is altering its glow. This irregular heartbeat points to dramatic variations in the terrain itself. One leading hypothesis is that vast patches of the surface have wildly different reflectivity. Imagine a world with continents of ancient pitch-black organic tar sitting right beside frozen seas of brighter, cleaner water ice. As this mottled surface rotates into view, its overall brightness would stutter and jump, creating the uneven pattern we observe. Another, even more dramatic possibility is the presence of a giant impact crater, a colossal scar so large it covers a significant portion of one hemisphere. Such a basin would have a different composition and texture than its surroundings, a profound dip in the landscape that would cast a literal and figurative shadow on the light curve. Or perhaps we are seeing the faint, blurred signature of geological features we cannot yet resolve, mountains or valleys on a scale we can barely comprehend. This unresolved light is a ghost image of its true topography, a map of albedo and altitude we are not yet skilled enough to read. What colossal features must exist on this distant world to make its light flicker in such a cryptic code? The cryptic flicker of its light curve is more than just a visual puzzle. It is a direct window into the eighth mystery, the enigma of Varuna's thermal inertia. When scientists point their most sensitive instruments toward this distant world, they measure not just its reflected light but the faint heat it emits. This thermal emission tells a story of how the surface absorbs and releases solar energy, and the story it tells is deeply confusing. The data does not match the predictions of any simple model. For a world so far from the sun, scientists expected a surface that reacts quickly to the tiny amount of heat it receives, warming and cooling with dramatic swings. Instead, the measurements suggest a surface with a kind of thermal memory, an ability to hold onto heat in a way that defies expectations. This property, called thermal inertia, is unexpectedly high. Think of walking on a beach on a sunny day. The dark, dry sand burns your feet because it heats up instantly, but the wet, compact sand nearby feels cooler. It has higher thermal inertia, it resists changing temperature. Now imagine that same principle on a planetary scale. What could give Varuna's surface this unexpected stability? One compelling theory is a surface blanketed in a deep layer of extremely fine dust. This fluffy, porous material would act like a cosmic blanket, trapping heat underneath and preventing it from escaping rapidly back into space. Another possibility is that the surface ice itself is not a solid sheet, but a frothy, porous layer full of tiny air pockets that provide superb insulation. This would be like the crust on a freshly baked loaf of bread, hard on the outside but soft and airy within, a structure that stubbornly retains warmth. This thermal anomaly forces us to reconsider the very texture of this distant world. Is its landscape a vast, silent desert of insulating dust or a fragile, frothy crust of ancient ice? The answer is crucial because a surface that holds heat differently could create unique microclimates, perhaps even allowing volatile ices to survive in shadows where they otherwise should not. Why does this one world cling to its warmth so tenaciously? And what does that stubborn heat reveal about the unseen landscape beneath our telescopes? The unexpected warmth held within its crust raises a profound question about its inner life. Could this distant, dark world be geologically active? This brings us to the ninth mystery, the potential for cryovolcanism on Varuna. On Earth, volcanoes spew molten rock, but in the deep freeze of the outer solar system, a different kind of eruption might occur. Cryovolcanoes, or ice volcanoes, would erupt with a slow, oozing slurry of water, ammonia, or methane ices, a thick, cold lava that slowly builds up into alien landscapes. For such a small and distant object, the idea seems almost ludicrous. The heat required to melt ice, even at these incredibly low temperatures, should have dissipated billions of years ago. Yet, the indirect evidence gives us pause. Its surprisingly high density suggests a rocky core, and radioactive elements within that rock decay over eons, producing a slow, steady trickle of internal heat. If Varuna is more rock than ice, this heat could be enough to maintain a slushy, subsurface ocean, a layer of liquid or semi-liquid material trapped between a frozen crust and a solid core. The pressure from within could eventually seek release, forcing this icy sludge up through fissures and cracks to slowly resurface the world. What might the signs of such activity be? We could look for unusually smooth plains, areas where fresh, bright ice has welled up and covered the ancient, dark terrain, or the telltale shapes of gentle, dome-like cryovolcanic constructs. While we lack the resolution to see such features directly, the very possibility forces us to reconsider the nature of cold worlds. They may not be the frozen, static tombs we once imagined, but places with their own slow, frigid heartbeat. Is Varuna a dead relic, or is it secretly alive, its interior still churning with the faint, residual warmth of its creation? The possibility of a hidden, slushy ocean raises a gravitational question of its own, one that orbits this world like a ghost. Where are its moons? This is the 10th mystery, the puzzling absence of any confirmed satellites around Varuna. In the distant Kuiper Belt, having a moon is almost the rule rather than the exception. Many objects of similar or even smaller size proudly host their own orbiting companions, tiny worlds locked in a slow dance around a primary. These binary systems are cosmic fossils, telling the story of gentle collisions and gravitational captures from the solar system's violent infancy. Yet, despite exhaustive searches, no moon has been definitively found circling Varuna. Its gravitational embrace appears to be entirely solitary. This void is a significant anomaly. Why is this particular world alone? One possibility is that its incredibly rapid spin creates a hostile environment for any potential moon. The same centrifugal forces that stretch its own body would make a stable orbit difficult to achieve and maintain. A moon would either be flung away or drawn inward to a catastrophic collision. Another, more dramatic theory points to a brutal past. Perhaps Varuna did have a moon, or even several, in the distant past, but a colossal impact with another object shattered them completely. Such a cataclysm could have also stripped away any nascent atmosphere and contributed to the world's current breakneck rotation, a permanent scar from an ancient war of worlds. This single event would have reset its entire history, leaving it the solitary spinner we see today. The lack of a moon forces us to ask a deeper question. Is Varuna's loneliness a product of its chaotic birth or the violent aftermath that followed? Its empty skies are a silent testament to a history far more tumultuous than its quiet, dark presence suggests. Its solitary nature extends far beyond its empty skies into the very path it carves through the void. The 11th mystery lies in the eccentricity and inclination of Varuna's orbit. This is not a simple, placid circle around the sun. Its path is an ellipse stretched and tilted, carrying it on a journey that climbs high above and dips far below the main plane of the solar system. Most planets and asteroids orbit in a relatively flat disk, like marbles rolling on a table. Varuna, however, moves more like a bee buzzing around that table, its path angled and oval-shaped. This specific orbital signature is a fossil record of gravitational events that happened billions of years ago. Such a path is rarely a product of a quiet, undisturbed birth. It is far more likely the result of a powerful gravitational nudge, a cosmic shove that knocked it out of a more circular, flat orbit and sent it on its current, looping journey. The prime suspect in this ancient disturbance is Neptune. In the early solar system, the giant planets are thought to have migrated, shifting their positions and scattering countless icy bodies in their wake. A close encounter with a young, wandering Neptune could have flung Varuna into its present peculiar orbit. Yet, the exact details of this encounter remain frustratingly unclear. Pinpointing the specific event is like trying to reconstruct a single car crash from the final position of one piece of debris millions of years later. Other large bodies could have been involved, or perhaps a series of smaller, cumulative nudges from various objects over eons. The uncertainty reveals a deeper truth, that the Kuiper Belt is not a serene graveyard, but a dynamic archive of the solar system's most violent and formative era. Why has Varuna's specific dynamical history proven so difficult to decipher? And what does its unique path tell us about the chaotic nursery from which it came? The precise dimensions of this distant world remain frustratingly just out of reach. This is the 12th mystery, a fundamental debate over Varuna's true size and mass. You might think measuring something so straightforward would be simple, but across the vast gulf of space, even basic facts become contested. Different scientific techniques have delivered conflicting answers, creating a persistent uncertainty about its most fundamental properties. One method relies on stellar occultations, a celestial game of peek-a-boo. Astronomers watch intently as Varuna passes in front of a distant star, its shadow briefly blotting out the starlight. The duration of that blink tells us the width of the object. Another method uses thermal emissions, measuring the faint heat radiating from the dwarf planet to estimate its surface area. The problem is, these two techniques do not perfectly agree. The numbers are close but not identical, leaving a margin of error that fuels scientific debate. Is it a little larger or a little smaller? This is not just a trivial disagreement over kilometers. The size directly influences the calculation of its density, which is the key to unlocking its internal secrets. If Varuna is larger than we think but has the same mass, its density would be lower, suggesting a more porous rubble pile structure. If it is smaller, the density shoots up, pointing toward a much more solid, rock-rich world. This discrepancy means we cannot yet be certain if Varuna is a fragile collection of ice and rock barely holding together, or a dense, consolidated body with a massive core. The very nature of its interior, the explanation for its rapid spin and strange shape, hinges on resolving this single, stubborn puzzle. How can we truly understand a world when we cannot even agree on how big it is? The debate over its size and mass leaves us staring at a world we cannot fully define, but the very skin of that world holds its own cryptic record. The 13th mystery is the age of Varuna's surface, a question written in the scars it has collected over billions of years. Every solid body in the solar system bears the pockmarks of cosmic collisions, a cratered history book where the number and size of impacts tell a story of time. A heavily cratered surface is ancient, a primordial landscape untouched for eons. A smooth surface, by contrast, is young, its old scars erased by some form of recent geological activity. For Varuna, reading this book is an immense challenge. Our best telescopes can only see it as a faint, unresolved dot, so we cannot directly count its craters. We are left to infer its history from indirect clues, and those clues are deeply conflicting. Its overall darkness suggests an ancient crust, one that has been thoroughly darkened by billions of years of radiation, a process that takes immense time. This points to a surface that has been sitting exposed, accumulating damage since the solar system's earliest days. Yet, the possibility of cryovolcanism and internal heat whispers a different story. If slushy ice has ever welled up from below, it would have paved over old impact basins, creating vast, smooth plains and resetting the geological clock. Its surface could be a palimpsest, a parchment where ancient craters are partially erased by younger, fresher ice. How can we reconcile an ancient, dark surface with the potential for recent renewal? One theory suggests a patchwork history where some regions are truly ancient and dark, while others, perhaps near tectonic fractures or cryovolcanic vents, are periodically refreshed. Another idea is that the darkening process is so efficient that even a recently resurfaced area would become dark again in a relatively short astronomical time, making it impossible to distinguish old from new with current data. Is Varuna a static fossil, its face unchanged for 4 billion years, or is it a world with a slow, cold pulse, still actively reshaping itself? The answer is frozen into a landscape we cannot yet see, a hidden chronicle of time itself. The chronicle of its surface is a tale told in scars, but beneath that frozen crust lies a possibility even more profound. Could Varuna, against all odds, conceal a hidden ocean? This 14th mystery delves into one of the most speculative and captivating questions about this distant world, the potential for a subsurface sea of liquid water. The notion seems to defy logic. Varuna is a small, cold body in the deepest freeze of our solar system, where surface temperatures hover near absolute zero. For liquid water to exist, a significant source of internal heat is required, and for a world this size, that heat should have been lost eons ago. Yet, the clues we have already gathered make this tantalizing idea not entirely impossible. Its surprisingly high density points to a substantial rocky core, and within that rock, radioactive elements like potassium-40, thorium, and uranium are constantly decaying. This process acts like a built-in nuclear furnace, generating a slow, steady trickle of heat that can persist for billions of years. This radiogenic warmth could be just enough to maintain a layer of slushy, briny water trapped between the solid core and the icy outer shell. Another potential heat source, though less likely for a solitary object, could be tidal forces. If Varuna had a more eccentric orbit in the past, or if it was once part of a binary system, gravitational flexing could have pumped energy into its interior, melting the ice from within. What would the evidence for such an ocean look like? We would search for signs of recent resurfacing, vast smooth plains where liquid or slush has welled up from below and frozen, erasing the ancient cratered terrain. We would look for specific chemical signatures on the surface, like ammonia or salts, which act as powerful antifreeze, lowering the melting point of water and making a subsurface ocean far more plausible. The ultimate test would be to measure Varuna's gravitational field in exquisite detail, as the sloshing of an internal ocean would subtly influence how the world wobbles as it spins. The existence of a subsurface ocean would transform our understanding of this dark spinner entirely. It would elevate Varuna from a frozen fossil to a potential habitat, a world where the most essential ingredient for life, liquid water, might exist in perpetual darkness. This raises a staggering question. If water can persist in such a remote and unlikely place, how many other hidden oceans are waiting to be discovered in the cold, dark depths of our own cosmic backyard? This solitary path through the void may not be entirely unique. Varuna's peculiarities find a strange and distorted mirror in another distant dwarf planet, the rapidly spinning and egg-shaped Haumea. Here lies the 15th mystery, an unexplained kinship that hints at a shared violent birth. Both worlds are cosmic speed spinners with days measured in just hours. Both possess elongated, stretched forms shaped by their relentless rotation. Most strikingly, both are the patriarchs of their own families. Haumea is surrounded by a retinue of smaller objects, its own moons and a collection of icy fragments that all share nearly identical orbits and compositions, the clear debris from a gargantuan impact. Varuna, too, is suspected to be the parent of a smaller collisional family, a cloud of shattered siblings traveling on similar paths through the Kuiper Belt. This is more than mere coincidence, it is a fingerprint. The evidence points toward a cataclysm in the early solar system, a time of unimaginable collisions. Could Varuna and Haumea be cousins, both born from the same type of shattering event? The physics of such a colossal impact are mind-bending to contemplate. A collision between two protoplanets would not just create a cloud of debris, it would transfer a tremendous amount of angular momentum, setting the largest remaining fragments spinning with the same frantic energy we observe today. The impactor would essentially deliver a glancing, cosmic blow that sent the survivors whirling like tops for billions of years. Yet the puzzle is not so easily solved. While the families exist, their specific orbits are different enough to raise questions. Did they originate from separate but eerily similar impacts in different parts of the primordial Kuiper Belt? Or could they be fragments from a single, even larger, catastrophic disruption that have since drifted apart over the eons, their orbital path slowly changed by gravitational nudges from Neptune? This celestial detective story forces us to look at the Kuiper Belt not as a collection of individual worlds, but as a crime scene. The spinning shapes and trailing fragments of Varuna and Haumea are the scattered evidence, and we are left to determine if they are the products of the same cosmic catastrophe or just similar tragedies in a violent and chaotic neighborhood. The very light reflecting from Varuna's dark surface contains a chemical fingerprint that refuses to be fully identified. This is the 16th mystery, a puzzle locked in its infrared spectrum, where certain absorption features present a code that scientists have not yet broken. When astronomers analyze the specific wavelengths of light Varuna absorbs, they find the expected signatures of water ice and some dark organic material. But superimposed on that are other, subtler dips and valleys in the spectral data that do not cleanly match any known ices like methane or ammonia, nor any common silicate minerals. It is as if you were analyzing a mysterious substance and found clear traces of salt and charcoal, but also a third, unknown ingredient that completely defies classification. This spectral anomaly suggests the presence of unusual compounds on its surface, materials that are either exotic in their own right or have been processed in ways we do not fully understand. One possibility is that we are seeing the effects of uniquely intense space weathering. The constant bombardment by cosmic rays on Varuna's specific mix of ices and organics could be creating complex new molecules, a type of cosmic chemistry we have not yet replicated in labs or observed clearly on other worlds. Another, even more intriguing idea is that these features are the calling cards of ices that have been heavily altered by heat and pressure, perhaps from that hidden internal warmth, creating crystalline structures or hydrated minerals that are uncommon in the frigid outer solar system. These unexplained lines in its light are a direct challenge to our catalogue of known materials. They force us to admit that the surface of this distant world is not just a simple mixture of ice and tar, but a complex chemical laboratory whose final product we have not yet learned to name. What unknown substances is Varuna silently harboring, and what do they reveal about the hidden diversity of chemistry at the edge of our solar system? That unknown chemistry on its surface plays a direct role in a deeply puzzling physical relationship, the 17th mystery of Varuna's albedo and temperature paradox. Common sense tells us that a dark object sitting in sunlight should get hotter than a bright one. A black car parked in the summer sun becomes an oven, while a white car stays comparatively cool. By this logic, Varuna's exceptionally dark surface should make it a relatively warm object for the Kuiper Belt, efficiently absorbing every precious photon of solar energy. Yet, the temperature measurements we have are confusing and sometimes seem to conflict with this simple expectation. The reality of its thermal environment is far more complex than a simple parking lot analogy. The key lies not just in how much heat the surface absorbs, but in how effectively it can shed that heat back into space. This is where the texture and composition of the surface become critical. If Varuna's crust is blanketed in that deep, fluffy layer of insulating dust, the heat absorbed by the dark top layer would have difficulty traveling downward or radiating away efficiently. It would be like wearing a black winter coat. The dark color absorbs the sun's rays, but the thick insulation traps your body heat, creating a complex thermal balance. The dark color tries to make it warm, but the porous, insulating nature of the material resists that warmth, creating a thermal tug of war. Another factor is the potential for subsurface ice to sublimate or turn directly from solid to gas. Even at these low temperatures, if the dark surface manages to heat a subsurface layer of volatile ice like methane, the energy would be used up in the process of sublimation rather than raising the temperature, acting like a built-in air conditioning system. This paradox forces us to see Varuna not as a simple, passive rock, but as a dynamic system where color, texture, and internal chemistry interact in a delicate energy balance. Why does this one world so stubbornly defy our basic expectations of hot and cold? The answer is written in the faint whisper of its thermal radiation, a signal that tells us its surface is not just dark but strangely and wonderfully complex. Perhaps its most defining feature, that dizzying spin, brings us back full circle to one of the earliest and most persistent ideas about its nature. Could Varuna actually be two worlds instead of one? The mystery of a potential binary or contact system refuses to fade, even in the face of inconclusive evidence. The hypothesis is elegantly simple. A contact binary would form when two smaller, separate objects drifted together so slowly and gently that they simply touched and merged like two droplets of water coalescing into one. This single, gentle collision could explain so much. It would naturally impart a tremendous amount of spin to the resulting combined body, accounting for that frantic 6-hour rotation. It would also easily explain the elongated, stretched shape we infer from its light curve, as the two lobes settle into a single, peanut-like form held together by their mutual gravity. The alternative is a close binary where two distinct bodies orbit a shared center of gravity. They're danced so tight and fast that from our distant vantage point, they blur into a single, flickering point of light. So why, after all this time, is this still just a compelling theory and not a confirmed fact? Our current telescopes, for all their power, simply lack the resolution to see such fine detail at such an immense distance. We are like someone on a distant shore trying to determine if a faint, blinking light is a single bulb or two bulbs held very close together. The irregular patterns in its brightness could be interpreted as the complex interplay of two separate bodies, each with their own dark and light patches tumbling through space together. Yet the same patterns could also be explained by a single, mottled world with dramatic variations in its terrain. The data is ambiguous and nature is not giving up its secret easily. This enduring uncertainty forces us to confront the limits of our own perception. Is Varuna a solitary world stretched by its own speed, or is it a permanent embrace, a cosmic partnership forged in the gentle collisions of the ancient solar system? Until we can send a probe to gaze directly upon it, this fundamental question of identity will remain one of its most profound and unresolved puzzles. This cosmic kinship leads us to a deeper classification puzzle, the 19th mystery of Varuna's place within the Kuiper Belt's great dynasties. Out in the distant dark, astronomers have mapped not just individual worlds, but entire families of objects, groups that share nearly identical orbital paths. These are the dynamical families, and they are considered the descendants of a single, massive parent body shattered in an ancient, catastrophic collision. Varuna's own orbital parameters, its specific path around the Sun, suggest it belongs to one of these great clans. Its journey through space seems to align it with a particular group of icy bodies, all tracing a similar, elongated and tilted route. This shared path is the primary evidence for a common origin, a fingerprint left over from a single, shattering event billions of years ago. If this is true, then every object in that family, including Varuna, should be fragments of the same original world. They should, in theory, share a common ancestry and thus a similar physical nature. This is where the mystery deepens dramatically. When we look at Varuna's physical characteristics, they do not always fit neatly with its supposed siblings. Its unique darkness, its puzzling density, and its incredibly rapid spin set it apart. Imagine a family where all the children have brown hair and blue eyes, but one child has bright red hair and green eyes. You would start to question if they truly share the same parents. That is the enigma with Varuna. Is it the largest surviving fragment of that primordial collision, a core piece that retained the most mass and a unique set of properties? Or could its orbit be a coincidence, a gravitational fluke that has grouped it with unrelated objects? Perhaps the collision that created its family was far more complex than we imagine, not just breaking a world apart, but also merging pieces in strange ways, creating a few anomalous children with wildly different traits. This classification problem strikes at the heart of how we understand the history of our solar system. Are these dynamical families clean, simple lineages, or are they messy, blended groups with hidden, turbulent pasts? Varuna's refusal to conform perfectly to its family's expected profile suggests our map of the outer solar system is still missing crucial, violent chapters. The relentless rain of radiation from the cosmos is slowly rewriting Varuna's surface. This gradual transformation, known as space weathering, is the 20th mystery, a process that darkens and reddens the crusts of airless worlds over billions of years. Yet on Varuna, this universal phenomenon seems to operate by its own unique rules, leaving a surface that appears far more weathered than many of its Kuiper Belt neighbors. Imagine an old wooden fence, silvered and darkened by decades of sun and rain, standing next to a newer fence that is still brown and fresh. Varuna is that ancient, silvered fence, while other objects nearby seem curiously preserved. Why has this one world aged so distinctly? The primary artists of this change are cosmic rays and the solar wind, a constant stream of high-energy particles that slam into the surface ices. These impacts break apart simple molecules like water and methane, freeing up atoms that then recombine into complex, dark carbon compounds, the tholins we have mentioned before. Micrometeorites, tiny grains of dust traveling at incredible speeds, also contribute, vaporizing tiny patches of ice upon impact and sintering the surrounding material into a darker, more cohesive crust. This should be happening everywhere in the Kuiper Belt, a slow, steady darkening of all surfaces. So why does Varuna stand out? The answer may lie in its specific environment and composition. Perhaps its rapid rotation and elongated shape create a more effective trap for interstellar dust, constantly sandblasting its surface and accelerating the weathering process. Or maybe its original composition was uniquely rich in the kind of carbon-based ices that are most susceptible to this darkening transformation, a primordial chemistry set that was always destined to turn black. Another possibility is that its lack of any geological resurfacing for an immense period has given space weathering an uninterrupted eon to do its work, creating a surface that is essentially the end product of this cosmic aging process. Its profound darkness is not a static feature, but a testament to an incredibly long and exposed history. What unique combination of location, composition, and history has made Varuna the most weathered face in its cosmic neighborhood? The secret is etched particle by particle into its dark skin. That profoundly weathered crust may not be as inert as it seems. Deep within the observational data, there are faint, controversial whispers of activity, the 21st mystery of unexplained outgassing events. On rare occasions, a few astronomers have reported a subtle, transient brightening of Varuna, a faint and fuzzy glow surrounding the pinpoint of its reflected light. This is the classic signature of outgassing, the sudden eruption of volatile gases from a world's interior, lifting clouds of reflective ice dust into the space around it. Such behavior is expected from comets, those icy wanderers that blaze with glorious tails as they approach the sun. But for a classical Kuiper Belt object like Varuna, a body presumed to be locked in a deep, permanent freeze, this is utterly unexpected. It would be like finding a dormant volcano you thought was extinct for 1,000,000 years suddenly puffing a small, defiant cloud of smoke. What could possibly trigger such an event on a world so far from the sun's warmth? The most likely culprit is a sudden, localized source of heat. One dramatic possibility is a meteoroid impact. A large rock slamming into Varuna's surface at cosmic speeds would deliver an immense and instantaneous burst of energy, flash heating a patch of subsurface ice and blasting the resulting vapor and dust into a temporary faint coma. Another, more intriguing theory involves the slow buildup of internal stresses. If Varuna does possess a subsurface ocean or pockets of volatile slush, the slow freezing and expansion of that material over eons could eventually fracture the rigid outer crust from within. This would create a new fissure, a vent through which trapped gases could suddenly escape, like a geyser erupting from a frozen landscape. The controversy stems from the fleeting and unconfirmed nature of these observations. The events are so subtle and brief that they sit right at the edge of what our telescopes can detect, making them impossible to verify with absolute certainty. Skeptics argue it could be a trick of the light, an artifact of Earth's atmosphere, or a misinterpretation of the complex light curve from its mottled surface. Yet the possibility remains tantalizing. If these outgassing events are real, they paint a picture of a world that is not entirely dead, but one that occasionally stirs in its slumber, reminding us that even in the deepest freeze, hidden forces are still at work. These faint whispers of activity only deepen the central puzzle of what lies beneath. The 22nd mystery forces us to peer directly into the heart of the matter, confronting the profound enigma of Varuna's internal structure. All the clues we have gathered, its frantic spin, its perplexing density, and its stretched shape, must converge somewhere deep inside this world, yet without direct seismic data or gravity maps, its interior remains a ghost, a phantom sketched only by the faint shadows it casts. The models scientists build are like architectural plans for a building they have never entered, based solely on how it wobbles in the wind. The most fundamental question is one of differentiation. Did Varuna, in its hot and violent youth, undergo the planetary process of separating into distinct layers, with the heaviest materials like rock and metal sinking to form a dense core, while lighter ices rose to form a mantle and crust? For a world of its modest size, this is not a given. If its density is on the higher end of estimates, it strongly suggests a differentiated interior, a world with a substantial rocky heart. This massive core would provide the gravitational anchor needed to withstand its centrifugal forces, preventing it from flying apart. It would also house the radioactive elements that could, even now, be providing the faint internal warmth needed to power a subsurface ocean or the occasional cryovolcanic burst. Yet another, more exotic model exists. Perhaps Varuna is only partially differentiated, a marbled world where vast blobs of rock and ice are still chaotically mixed together, like a cosmic fruitcake that never fully settled. This peculiar internal arrangement could explain the conflicting clues, offering a structure that is dense enough to be stable, yet heterogeneous enough to account for its irregular shape and complex gravity field. The shape itself is a critical clue. A simple, homogeneous body spinning that fast would be a nearly perfect ellipsoid, a smooth oval. But the bumps and wiggles in its light curves suggest its form is more complex, hinting at variations in internal density, as if massive, rocky continents are submerged beneath its icy shell, subtly tugging at the world's overall form. Is Varuna a neatly layered world with a secret, rocky core? Or is its interior a primordial jumble, a frozen relic from the solar system's very first days? The answer defines not just its present but its entire history, a story of formation and heat that is locked away in absolute darkness, waiting for a future mission to finally read its pages. That hidden interior, a ghost sketched only by inference, casts a long shadow on something we should be able to measure directly, its fundamental brightness. The 23rd mystery revolves around Varuna's absolute magnitude, a specific and careful measure of its intrinsic brightness, how much light it truly emits if everyone could see it from the exact same distance. This number should be a stable, reliable fact, a cornerstone for calculating everything else about the world. Yet it is not. This core measurement flickers with uncertainty, creating a persistent ripple of confusion through all our models. Why does this one number refuse to stay still? The problem begins with Varuna's extreme darkness and its complex, mottled surface. Absolute magnitude is calculated by observing how its apparent brightness changes with its distance from the Sun and Earth. But this calculation assumes a simple, uniform world. Varuna is anything but. Its surface is a patchwork of pitch-black terrains and slightly brighter icy regions. As it spins, this uneven surface presents a constantly shifting face to our telescopes. One moment we might be measuring the light from a vast, dark plane, and the next a slightly brighter region rotates into view. This means that depending on when and how we observe it, we can get slightly different readings for its absolute magnitude. A faint reading suggests a larger, darker world that absorbs most of the light that hits it. A brighter reading points to a smaller, more reflective object. This is not a small discrepancy. It directly fuels the ongoing debate about its true size and density. Think of trying to judge the true color of a spinning disco ball with both black and mirrored tiles. From a distance, its overall brightness would seem to pulse and change, making it impossible to be certain of its average color. This is the challenge with Varuna. Its unpredictable flicker of intrinsic light makes it a moving target, ensuring that even its most basic property, its fundamental brightness, remains a subject of active investigation and debate. That fundamental uncertainty in its very brightness forces us to look beyond our solar system for answers, to a relentless rain of energy from the depths of the galaxy itself. The 24th mystery explores the profound influence of galactic cosmic rays on Varuna's surface, a slow-motion nuclear chemistry experiment playing out over billions of years. These are not mere particles of light. They are atomic nuclei stripped of their electrons and accelerated to nearly the speed of light by distant supernovas and black holes. This torrent of high-energy radiation constantly bombards Varuna's airless surface, and each impact is a tiny blast of energy that shatters the molecular bonds of the simple ices lying there. Think of it as an invisible cosmic sculptor chiseling away at a frozen block of water and methane, not to change its shape but to rewrite its very chemical identity. The simple molecules are broken apart, and the fragments carbon, hydrogen, oxygen, and nitrogen are sent ricocheting across the frozen landscape. When they finally recombine, they form entirely new substances, complex organic polymers known as tholins. This is the same process we suspect creates the dark, reddish gunk on other outer solar system worlds, but on Varuna, it may be happening with a unique and devastating efficiency. Its extreme darkness could be the ultimate product of this relentless irradiation, a crust that has been essentially cooked into a thick layer of cosmic tar. This process could directly explain those unexplained spectral features, the strange chemical fingerprints that our laboratories cannot yet fully identify. We might be seeing the spectral signatures of exotic molecules that only form under such a sustained and brutal bombardment, compounds that do not exist naturally on Earth. Is Varuna's surface a vast repository of complex organic molecules created by the galaxy itself? The possibility is staggering, suggesting that the building blocks of life are not just a local phenomenon, but are being manufactured and scattered on worlds throughout the darkest reaches of every solar system. All of these puzzles, from its frantic spin to its hidden heart, lead us to the final and most pressing mystery, the one that points directly to our own future in space. We have pushed our Earth-bound telescopes to their absolute limits, and still, the fundamental truths about Varuna remain just out of reach. The only way to solve these enigmas is to go there. A dedicated space mission to this distant dwarf planet would be one of the most ambitious voyages of discovery ever undertaken, a journey to answer questions we can currently only guess at. Imagine a spacecraft finally entering orbit around this dark, spinning world. Its first task would be to map the entire surface in stunning detail, revealing the true nature of that uneven light curve. Are those variations caused by vast impact basins, sprawling dark planes of organics, or the subtle bulge of a contact binary shape? Cameras would see it all, resolving the ghostly image we have struggled with for decades into a clear, tangible landscape. A suite of spectrometers would then taste the surface, definitively identifying those unexplained chemical compounds and mapping their distribution. We would know, finally, the exact recipe of ices and complex organics that paint this world so dark. But the most profound revelations would come from beneath the crust. A precise measurement of its gravitational field, achieved by tracking the subtle wobbles of the orbiting probe, would tell us once and for all about its internal structure. Is there a dense, rocky core? Is the mass distributed in a way that suggests a differentiated interior or a chaotic, marbled one? This one measurement would solve the mysteries of its density, its ability to hold together, and the potential for a subsurface ocean all at once. The biggest questions of its formation and evolution hinge on this data. Did it form from the gentle merger of two primordial bodies, or was it sculpted by a single, shattering impact? Is it a static fossil from the dawn of the solar system, or a world with a slow, cold geological pulse? Its current, solitary state is a story we cannot yet read. A mission would analyze any trace of a tenuous atmosphere and search for even the tiniest, undiscovered moons, clues to a potentially violent past where companions were stripped away. Varuna represents a whole class of mysterious worlds in the outer solar system, and by understanding its unique history, we unlock a clearer picture of how all planetary systems, including our own, are built. The greatest unknown is what we have not even thought to ask. What stunning surprise is waiting, hidden on that dark and spinning frontier that will force us to rewrite the textbooks once again? From its dizzying 6-hour spin to the profound darkness of its weathered crust, Varuna stands as a collection of 25 interlocking puzzles. Each mystery, from the absence of an atmosphere and moons to the paradox of its shape and density, challenges our fundamental understanding of how distant worlds form and evolve. We are left to wonder about the secrets locked within its hidden interior, the potential for a subsurface ocean, and the unexplained chemistry written in its infrared light. The possibility of cryovolcanism and fleeting outgassing events hints at a world that may not be entirely dormant, while its disputed size and flickering absolute magnitude remind us of the limits of our own vision. Its kinship with Haumea points to a violent collisional birth, and its unique space-weathered surface acts as a cosmic clock, recording eons of bombardment by galactic rays. These enigmas, from its peculiar thermal inertia to the enduring question of whether it is one world or two, are not isolated curiosities. They form a single, grand mystery that transforms this distant speck of light into a profound question mark. Varuna compels us to look deeper and to venture farther, reminding us that some of the solar system's greatest secrets are still spinning in the frozen dark, waiting to be understood. Which of its 25 mysteries captures your imagination the most? Let us know in the comments